So I'm here with Anthony at the Sensorica lab. We worked on some open source hardware for a few days. So Anthony's from Cornwall,
Yeah.
and he's a mechanical engineer. And in his free time, he worked on an open source hardware project, and he brought it at the Sensorica lab because we wanted to see how well it works. And this is an air exchanger. You can call it.
Technically, you would call it a ventilator if you want to Google the term, but that's kind of confusing. So it's good to call it an air exchanger. Yeah.
An air exchanger, okay? So imagine that you are in your house and it's winter and you want some clean air from outside. What you normally think is opening the window, but what happens is that the hot air from inside it's gonna flow out, and you gotta get cold air from outside, right? So if you wanna save energy on heating, that's what the device is doing. So it's taking your hot air from the inside to shoot it outside, but before that, it hits the cold air that comes from outside. So there's an energy transfer, right? So the hot air from inside, the hot from that air, the energy goes into the air that comes from outside. And that happens inside this
Machine.
air exchanger, this machine, right? So what is the efficiency? So you calculate it, right? You calculate the efficiency of the
It's a
heat
bit less
transfer.
than 90%.
A bit less than 90%.
For the sensible efficiency, that's the heat you can feel, and the water vapor is about 40 to 50% efficiency.
Okay, cool. So now the device is working, right? And we can hear the motor. I'm just gonna turn it up a little because you know when you think about putting this in your room,
Yeah.
can you sleep with it, right? So you spend a lot of time reducing the noise. So
If you turn it up to medium, that's like a typical level you might actually use. If you turn it up to, this is on maximum now, I think.
yeah, so this is maximum noise, right?
Yeah. So that's quite a lot of air too. Most people aren't gonna want that much air. They don't need that much
Okay.
air.
So that is the minimum, and this is the medium, right? This is the medium here, which is like a ventilator. I mean, it's like any ventilator that you would have inside your.
It makes more noise when it's on this table like that. but
Okay,
yeah.
perfect. So let's see how this works, because this is done to mount on a window, but the whole idea here is to talk about this device as an application for RVs, okay, recreational vehicles. So this is we want to see if people are interested in that, people that are lovers of nature. But this was made for an apartment. So imagine this is the window, right? This is the window frame. So you mount it on your window frame. And essentially, that part is in your room, and this part is outside, right?
Yes.
So you kind of have air that gets sucked in here, which is hot, and then it gets transferred to the cold air that goes into your house with 90% efficiency. So you get the oxygenated air from clean air from outside into your room without losing heat, right?
Without losing very much heat. Yes.
Okay. So why did you work on this? I mean, what was in your mind when you started to work on this device?
I moved to Cornwall and I bought a house there, but the previous owners of the house had quite a number of animals in there for quite a long time, and they did not keep it very clean. So I scrubbed it for months, and I got most of the smell out, but not. There was still, during the winter when you close all the windows and there's no fresh air, there was still a very noticeable smell of these pets. Like just the fur and stuff.
Yes.
And so I hopped on the internet to try to find some solutions for this, and you can buy big energy recovery ventilator units, but you can't buy the little ones. Cost almost as much as the big ones. What
is the price for commercially available ventilators?
A good one is the Lunos E2, for instance. Is one that you might buy. Is a similar flow rate and efficiency of this model.
Yes.
That would set you back about 1,400 Canadian plus tax, plus shipping, plus whatever, I don't know else. So they're quite expensive. And then the big one for a house is more like $2,500, something like that. That's going to get you 10 times as much flow, but it's way too big for like a single room.
Yes.
And you have to have a plumbing, a ventilation system and stuff like that, which I don't have in my house, so yeah.
Okay. So this is an open source project, right?
Yes.
Okay. Open source means that you have a website and you put the plans there, so people can make it themselves if they're interested, and that's the purpose of this discussion here, is to see if somebody in the RV community would be interested to work with Anthony to reproduce. It's already a working prototype, so we're talking about beta here, right?
Yeah, beta
Okay,
model.
so that's the question. Is somebody in the RV community interested in taking this and with Anthony fitting it to an RV size and whatever, the trap on top, the dimensions, there are some standards, to work on essentially it's mechanical transformation, the box to fit it into that truck, right?
Yeah.
Okay, so is there anybody that would be interested in that? So why RV? Because we were here and we're saying, yeah, this is nice, it's neat for a house, for a room, but two summers ago, somebody gave us an RV to go on vacation, and we went along the St. Lawrence River east on the North Shore, and it gets pretty cold even during the summer. So imagine you're two people sleeping in this small space, and it's cold outside, and you're rebreathing the same air, right? So you're rebreathing the CO2 that you're producing, and not only that, but you're also sweating. And all that sweat gets on the windows, gets on the cold surfaces, if you want a fresh air in that closed environment, you would have to open your ventilation, but that means that your heat is going to go up, right? And so for that kind of small space where two people breathe the same air, and with that humidity problem, we thought that this could be a pretty neat solution. To replace just the ventilation that is already installed with this heat exchanger ventilator, right? So you keep your heat inside the truck, but you still have nice oxygenated air that comes from outside, and you have a close to 90% efficiency of heat transfer, right? Cool. Okay, so let's talk a little bit about the technical stuff. Now we know that air comes in from one side. And comes in from air goes out from one side and comes in from the outside. What is there are commercially available tools like that, devices like that. You made it open source. So what is different, or what is special? What were the challenges? What is the mechanics inside? Can you just walk us through a little bit how it functions?
The challenges of making it, or the challenges of designing it?
Yeah, maybe design. How much time did you spend on it first?
Maybe 8 months or something.
8 months.
6 months, 8 months, something like that, depending on how you count it. Because it wasn't 100% full time, right? So.
How many iterations? How many versions of this device?
Like 20 at least 20.
20 versions. So you sunk a lot of time. You sunk probably a lot of money because you had to buy new parts, new bearings,
I have a massive scrap pile, unfortunately. Yeah.
Yes. And so everything, all the case is 3D printed. Most of the parts are 3D printed, right?
Yeah, most of the parts.
Okay. There is some electronics inside. Essentially, it's what?
There's some electronics. There's some motors. There's a belt. There's some screws, and the central heat exchanger core is actually made of these coffee stir device things.
Okay, so you want to tilt it and then just see how this works.
Sure. So you can see in there. There's a rotating thing in the middle.
So there's a rotating thing here in the middle, right? It goes like this.
Yeah, and there's two fans. One to suck indoor air in this part, and then blow it outside to the great outdoors. So
air goes in here and comes out of there, right?
That's right.
And from the outside, air gets sucked in here.
Yeah.
And it gets blown inside there.
That's right.
Okay, so the air that goes in here transfers the heat to the air that comes this way.
That's right.
Okay, perfect. And through this rotation thing.
Yeah, to there's inside there's a cylinder which has a very large number of parallel channels, flow channels in there. There's 4,100 straws, and each straw has at least 2 channels, and there's a channel between the straws too. So it's like 12,000 channels or something in there, about 1.5 millimeters in diameter. And
so you can think of it as a very porous material that lets air flow through it easily in one direction, and then that material is the intermediary. So okay, so the hot air goes here, the energy gets stored in that material.
Yeah, and then the whole thing, it's always rotating. So the energy gets stored and then it gets rotates to the other side.
Yes.
And the energy gets released again.
Okay, perfect. So in terms of electronics, what do you have? You have fan, why do you have a microcontroller in this thing?
All the microcontroller does right now is controls the fan speed, but there's also sensors for temperature to compensate the fan speed for any kind of wind. Helps to improve efficiency. In the future, for a couple bucks, we can add some Wi-Fi functionality so that it's got Internet of Things.
Okay, that's interesting. So you can have it on your phone, let's say.
Yeah, you can control it with you can give it a schedule to turn on and off at certain times, or up or down at certain times. And it'll tell you what efficiency it's getting and stuff like that.
Okay, so there is a bit of automation here. There's some close feedback
Not yet,
loops.
but that's why we have a microcontroller. So like in the future, we can do that.
Okay, perfect. So it's an open platform, right? If somebody wants to push it forward. So okay, so let's say for RVs, it's not just the box that has to fit inside a hole of the fan, let's say, but it's also some collaboration with people from this community to add more features to it, right? So
yeah, and also solidify the features that are already there. Beta testing to make sure there's no issues.
yes.
Right.
You're talking about beta, right? How confident are you in this device per se? Like if you let it run, let's say 24 on 24, is it something that is flimsy? I mean, it doesn't make a lot of noise.
This one's been running for 2 months already.
It's been running for 2 months.
Yeah.
Okay, perfect. So it's good for a product. And this is not a product. Okay, so the whole idea here is to find somebody in the RV community that would like to partner with you. But you obviously sunk a lot of time and a lot of money in doing this, and maybe a perfect arrangement would be if somebody wants to collaborate with Anthony, and Anthony can help in a sense that instead of sourcing all these parts to put it together, it's open source, so you can go to the website and build it yourself and 3D print out the parts and order the electronics. But maybe one nice collaboration is to thank you for all this sunk time and costs, okay, buying parts, and you can just ship them a kit, right?
Yeah,
with the required parts.
Seems like a sensible thing to do. Is I already have quite a number of these parts that are required to make the machine, so I can assemble kits and send them out to people, and then you don't have to buy like 20 bearings or whatever. You just need the 2 bearings that you actually need.
Yes.
Stuff like that, and also you don't have to wait for shipping and stuff.
And if somebody doesn't have a 3D printer, or it's not experienced enough with the 3D printer, you can also do.
I can
send the 3D.
You can print the parts and send them to you as a whole kit, so you have everything you need in front of you to assemble a unit. I'm looking at there's an organization called Wikifactory that's offered to help me print them on a large scale.
So since this is all made of 3D printed parts, the whole idea here for this collaboration is that somebody comes up with a different form factor, right? Anthony can help to modify the CAD files to adapt, right? So this kind of thing, and maybe there could be an arrangement of some people helping you for your time for customizing it for their own thing.
Yeah,
but I think the easiest thing to do is to have one working already as it is, and then move towards customizing it for an RV, or I don't know. I'm just shooting.
That would make sense. Yeah, I think it would probably work pretty well for an RV the way it is. I'm not sure if I would put it in the ceiling, maybe in the back of the thing, because the rain is going to hit it.
Yes.
But if you put it in the back door, for instance, that would be a good spot. That would be very sensible, I think. It already runs on 12 volts, so.
This runs on. This is very important because all the RVs they run on 12 volts. Okay, so you have an adapter. It's plugged into the wall, but that adapter here. Can I just unplug it?
Sure.
Okay, so this adapter here, it's 12 volts DC into the box, right?
Yeah.
No, it just stopped, right? It just stopped.
Yeah, it turned off.
Okay. So if somebody in the RV community is interested to play with Anthony with this air exchanger, where can they find you?
Just go to the website. It's openERV.org. So.
And Twitter, right? They can find a Twitter handle. They can engage on Twitter.
Yeah, there's a contact me section on the website. It'll just
perfect.
give
Yes.
my Twitter.
So www.openerv.org, right?
That's right.
Okay, so this is where they find to contact you, and they also find the plans if they want to play with it. Mm-hmm. And there is always this thing in the sharing and collaborative economy. If you want to just download and try it yourself at home, it's always better to contact Anthony, because it's nice to have a recipe of a cake. You will never get the cake the first shot, right? So if you don't want to waste a lot of time, just contact Anthony, and even if it's open source and you have all the plans, you'll never get it right from the start, because there are some technical challenges here, and probably even the 3D printing is not so straightforward, right?
Yeah, I have tried to produce guides. Like there's a rudimentary guide on the websites to help you print it and assemble it, but nobody has actually done it yet, except me. So yeah, it would be nice to have some collaborators on the subject.
Nice. Anyway, so yeah, this is pretty cool, to be honest. It's the first time I'm holding it in my hands. I've seen it in posts, in videos. I've seen other parts laying around the table with wires everywhere. Now it's nicely packaged. I'm really happy that you brought it to this thing, and I hope you're gonna find somebody that gets excited about this. Somebody that is handy, has some technical skills, is not afraid to assemble a kit at least and 3D print some parts. But anyway, you have the mechanical engineer here, so you can trust him for help. Thank you, Anthony.
Thank you, TB. That was very helpful.
Perfect.